Hello students, I am Anamika and in the previous class we have solved exercise 1.1 and in this video we are going to solve exercise 1.2. So our first question is, which of the following are example of the null set? So in the first class we have discussed that a null set is a set which does not contain any element. That is, if we have a set S, then it does not contain any element, that is 5. So our first question is set of odd natural number divisible by 2. We know that natural numbers, that is odd natural numbers, starts from 1, 3, 5, 7 and so on. And we know that any of this number is not divisible by 2. So there is no element that is odd and divisible by 2. So here S is 5. Since any element of this set will not be divisible by 2. So it is an example of null set. Our second question is set of even prime numbers. We know that prime numbers are 2, 3, 5, 7 and so on. And we know that 3, 5, 7 are odd numbers but 2 is even number. So if we write this set S is equal to, then there is an element 2 which is even prime numbers. So S is equal to 2. So it is not empty set since it contains the element 2. So this is not an example of empty set. Our third statement is X such that X is a natural number where X is less than 5 and X is greater than 7. And we know that if X is less than 5 and natural number, then X will be 1, 2, 3, 4. And we have that X is greater than 7, then it will be 8, 9, 10 and so on. And we know that N means intersection. Intersection means common element. So is there any common elements? No, because first set contains 1, 2, 3, 4 and second set contains 8, 9, 10 and so on. So there is no common element in both the set. So it is an example of null set. That is S is equal to 5 and this is an example of null set. Our fourth statement is Y such that Y is a point common to any two parallel lines. So if we draw two parallel lines, for example A, for example B, that is A, that is B. We know that parallel line never intersect each other. So we will never find any point where they will be intersect. So this is an example of null set, that is S is equal to 5. So this is an example of null set. Our second question is which of the following sets are finite or infinite? And we know that in the previous class we have discussed that finite sets are set where elements are countable, that is we can count how many elements are present in the set. So our first statement is the set of months of a year. And we know that in a month there are 12 months. So we can count it. So it is an example of finite set. Finite set. Our second statement is 1, 2, 3, 4, 5 and so on. So we cannot count it. This is not countable set. So this is an infinite set. Since there are infinite numbers of elements. That is 1, 2, 3, 4, 5, 6, 7 and so on. So it is infinite. Our third statement is 1, 2, 3, 4, 5, so on up to 100. So here we can count it, we can say that there are 100 elements, that is 1, 2, 3, 4, 5, 6 and so on up to 100. So there are 100 elements, that is countable set. So it is an example of finite set. Our fourth statement is the set of prime numbers less than 99. So if we want to calculate how many numbers are there, that is prime numbers and less than 99, we will be able to count it. So this is an example of finite set. Let's come to the next slide. Our third question is in the following set, state whether A is equal to B or not. So here A is equal to A, B, C, D. Here B is equal to D, C, B, A. And in the first class we have write that B is equal, we can write it B as A, B, C, D also. since all the elements of A are present in the set B, so this is equal to A is equal to B, that is both the set are equal set. Our second question is A is equal to 4, 8, 12, 16 and B is equal to 8, 4, 16, 18. But in A, there is the extra element that is 12, which is not present in the set B. Since 12 is not present in the set B, then both are not equal set. Since A contains an extra element which doesn't belong to the set B, so they are not equal set. Our third statement is A is equal to 2, 4, 6, 8, 10. B is equal to x such that x is a positive integer and x less than or equal to 10. That is, x is a positive integer. Then it will start from 1 positive even integer. So then it will be 2, 4, 6, 8 and less than equal to 10, that is 10 will be there. That is 2, 4, 6, 8, 10. B is equal to 2, 4, 6, 8, 10 and A is equal to 2, 4, 6, 8, 10. Since both are equal, since all the elements of A are present in the set B, that is A is equal to B. So our fourth statement is A is equal to x such that x is a multiple of 10 and B is equal to 10, 15, 20, 25 and so on. Here, if we want to write A in roster form, then it will be 10, since it is multiple of 10, so it will be 10 into 1, then 10 into 2, that is 20, then 10 into 3, that is 30, 40, 50 and so on. And B is equal to 10, 15, 20, 25 and so on. Since 15 and 25 does not belong to the set A, thus A and B are not equal set. A and B are not equal. Our fourth question is, are the following pairs of sets are equal and give reasons? So here, first statement is A is equal to 2, 3, B is equal to x such that x is a solution of x square plus 5x plus 6 equal to 0. So first of all, we will solve this equation, that is x square plus 5x plus 6 equal to 0. That is x square plus 3x plus 2x plus 6 equal to 0. That is x into x plus 3 plus 2 into x plus 3 is equal to 0. So here x is equal to minus 2 and minus 3. So A is equal to 2, 3, but B is equal to minus 2 minus B is equal to minus 2 and minus 3. Since both the elements in the set A is not equal to the elements present in the set B, so both the set are not equal, that is A is not equal to B. That is sets are not equal. Our second statement is A is equal to x such that x is a letter in the word follow and B is equal to y such that y is the letter in the word wolf. So if we want to write A in roster form, then it will be F O L W. B is equal to W O L F. And in the previous class, we have discussed that it can be written as F O L W. Since all the elements of A present in the set B and all the elements of B present in the set A, thus A is equal to B. Thus A and B are equal sets. So that's all for today. Thank you, students.